Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students. Right, in the last session we discussed about, we just started definitions of a sag. We just discussed about sag, the definition of a sag, right? Mainly what are the different components, right? What are the different components in our overhead transmission system, right? And we discussed, so what are the components? Those are conductors, right? Supporters, right? Insulators, right? Cross arm, and some miscellaneous things that we discussed briefly. So after that we entered into the sag calculations, right? And we discussed about the definition of a sag, right? Before going to that, we discussed about span. So what is that span? The distance between the towers of a transmission line. This we can call it as a span, right? For a LT cable, so how much span? 45 to 60 meters. For high HT means high tension. High tension means high pressure. That means high pressure high voltage cables. It should be 65 to 80 meters length. We discussed about. So after that, we discussed ground clearance. So what is the ground clearance? It is the distance between from the ground to the lowest point of the conductor. For suppose if the conductor is, this is two transmission line towers, and we place the transmission line like this. So whatever the lowest point, that means the middle point, so from that ground, so this is called ground clearance, right? For our conveniency, for our safety, this ground clearance must be very high when compared to transmission, whatever the system it is. So the ground clearance must be as large as possible, for a safety considerations, right? And after that we discussed about sag, right? So what is the definition of a sag? So we already know the definition of a sag means this is a two transmission line. So you can place the conductor like this. The height of this supporters, it is the distance between the height of the supporters to the lowest point of the conductor. So this is called sag. So what is a sag? The definition of a sag means the distance between height of the supporters to the lowest point of the conductor. We can call it as a sag. Alright. So there are two ways. Basically, there are two ways to fetch the transmission line between the transmission towers. Alright. So there are how many ways? There are two ways. Two ways to fetch the transmission line, that means conductor, between the transmission towers. Alright. So there are two possible ways. The first possible way is, right, first possible way is transmission line that can be connected structurally, that means tightly connected, right? Tightly connected. Another possible way is loosely connected. So this is called loosely connected. Alright. So what are the advantages and disadvantages when it connected tightly and when connected loosely? Right. So what is a sag here? This is a max. So this is the lowest portion. So this we can call it as a sag. Alright. Now first you will take the tightly connected system. So tightly connected system. Now we'll discuss about if the transmission line which is connected tightly between the two transmission system, definitely the conductor material will be saved. No? right? So the conductor material will be saved, na? The cost will be, so somewhat we are reducing the cost of that conductor materials, right? So after that, maximum ground clearance, na? So you don't have any towers. So in order to maintain the ground clearance, you require a towers, right? Height of the towers. So you have to take high possible towers, right? Height possible towers. With the help of tightly connection, no need to have, because you have a particular ground clearance is very high. When you are tightly connected, the ground clearance is high now, right? Ground clearance almost all high when compared to the lightly connected, right? Loosely connected. So this is a ground clearance for this loosely connected, right? Which one is high? Tightly connected is very high. So there is no need to take care of high, very high possible towers, right? After that, right? No need to go for height towers, right? If you are taking height towers, means definitely it will require some operating cost, some installation cost, and all these things will get. Next, these are the advantages, right? And what about this? When you are connected tightly, what happens? The tension will be very high, right? Tension is very high. Tension is nothing but the force, right? The force which moves something, right? So tensile strength, that means the force which moves something. For suppose there are two persons, right? So these two persons carrying a wire. So there are too much stress, means whatever the force that acting from here this side, another force acting from this side. If it is too much stress, there must be a possible of breakdown. Right? So if our tension should be very high, means there must be a possible of breakdown. In this case, tightly connected case, the tension is very high now. So from that there will be a breakdown occurs. Right? If the breakdown occurs, there is no power supply. So that is an interruption. So we don't require these type of thing. Right? After that, if it is loosely connected, system, right? So the conductor materials required. So what is the conductor materials required? It should be loosely connected, na? So the conductor material should be very high. Material required is high, right? So we require loosely connected, means a tower ground clearance ఎలా ఉంటుంది? Less ground clearance, less, right? So in order to increase the ground clearance, we require high towers, right? High towers you require. So these are disadvantages, right? So what is the advantages? The strength, that means that the tension is very less. Less, right? If a tension is less, definitely there will be no chances of a breakdown. That means the tension must be within the limits, or tension should be very less. So that's why there is no breakdown occurs in this type of curved nature, right? So the tightly connected system, that it has some advantages and some disadvantages. For a loosely connected system, that it has some advantages and some disadvantages. So for this, we have to combine both this tightly connected system and loosely connected system in order to erect the best design of a transmission system. We ensure that the perfect sag should be maintained, and the tension must be within the limits, and the conductor materials must be in the savings condition. Ground clearance must be a possible thing. So these are clubbed together. We built a system, we built a design with perfect sag consideration. If your sag must be perfect, means the tension must be within the limits. You don't have that much tension, right? You don't have that much very less ground clearance, right? So with clubbed together, we can ensure that a perfect sag can be defined, right? So that's why from these two will combined, will go for a somewhat loosely connected. It should be maintained some sag in order to get the best design of a transmission line, right? So that's why you have to take a perfect sag must be within the limits, or not that much high, not that much low. If that much high means the ground clearance will be very less. If the ground clearance will be very less means there is no safety for a peoples, right? Now we'll see. Right, so these are the towers, right? We are placing the transmission lines, right? So we are placing the transmission line A, B. So this is called span, right? Between the two towers, the distance between the two towers, we can call it as a span, right? If the distance means span greater than 1000 feet. See, this is very important question. If the distance between the two towers, so that is nothing but span, which is greater than 1000 feet, so then the shape is nothing but the shape of a transmission line curve is a catenary. Very important bit. Right? That means if the distance between the two transmission lines, that is nothing but a span, so which is greater than 1000 feet, so then we can call it as a then the shape of this curve, so we can call it as a catenary, or below less than 1000 feet. Below less than 1000 feet, so then this is the shape of the transmission line, we can call it as a parabolic, right? Then the shape of a transmission curve is nothing but parabolic, right? Now we are using a high voltage HT transmission line, or all almost all 110 meters to 130 meters only. 110 meters to 130 meters, that means which is less than 1000 feet, right? Now that's why all the shape will be parabolic shape nowadays. The power transmission line shapes are a parabolic shape, because the length of the transmission line should be, transmission line means the length of the span should be 110 meters to 130 meters only. That means within the less than 1000 feet. 1000 feet is nothing but 1000 feet means almost all, I think 380 meters, right? 1000 feet is nothing but 380 meters, right? So whatever it may be, I don't have that much figure on this. So which is less than 1000 feet, that's why the shape of the curve is a parabolic. Nowadays all the transmission line shape is a parabolic. So this is very important question. Alright, but if the shape is catenary, we'll get accurate result. That means if the shape is a catenary shape, we'll get accurate sag value, accurate tension value. All these things we'll find out. Alright, so now what you discussed, the important note, what you discussed means the distance between the two towers is nothing but so we can call it as a span, right? If a span is less than 1000 feet, so then we can call it as the shape, we can call it as a catenary shape, right? If it is, that means if greater than 1000 feet, that the shape you can call it as a catenary shape. If the span is less than 1000 feet, then the shape is called parabolic shape. Nowadays all the transmission line shapes are a parabolic shape, not the catenary shape. But if the shape is quaternary shape, we'll get the accurate value of a sag, the accurate value of a tension. Right? So from that, we have to know few references, right? We'll discuss about few references. Right? So what are the references? We'll see. I'll draw one more time. Always we have to take the bendings. మనం straight line ఎందుకు తీసుకోము? Why? Because definitely the tension will be very high. If the tension is high, we'll see. For suppose if this is true, tightly connect చేసావు. సో ఏమవుతుంది, టైట్గా సాగదీసాం అనుకో, ఆటోమేటిక్గా ద ప్రెషర్ ఆన్ దిస్ కండక్టర్, దిస్ టవర్. సో టవర్ ఏమవుతుంది, ఇట్లా వంగిపోతుంది. సో ఇఫ్ ద టవర్ వంగిపోయిందంటే డెఫినెట్లీ ఇట్ విల్ గెట్ ట్రబుల్. ఆర్ ఎల్స్ టెంపరేచర్ ఇంక్రీజ్ అయిందనుకో, హాట్ కండిషన్లో whatever the transmission line gets evaporated, that means expanded. If it is expanded, the breakdown will be occur. Right? So these are the conditions, but we don't have that much concept on this. Right? So what are the references? Right? So this is the two towers. So you are having the transmission line. So these are the towers. Right? You are having the transmission line. The first point. Right? The first thing. So the first reference or first thing taken out from the figure itself, from the sag figure itself. That means first influence. Right? The first one is, if the load assumed to be, that is uniformly distributed throughout the length, na? Right? If the load is assumed to be uniformly distributed at center point, so that means load is uniformly distributed and concentrated at center, middle of the transmission line, then the shape of the curve is quaternary. The first observation that we made it is, if the load, that means each and every transmission line should carry some load, na? If that load is uniformly distributed, right? Definitely the transmission and parameters are distributed parameters. So that load is uniformly distributed, but the concentrate on midpoint of the load. So then the shape is a quaternary shape. So after that, if the load is uniformly distributed throughout the length, you don't have any concentrate on a midpoint and all these things. Throughout the length, the load is acting. So then the shape is parabola. Very, very important. Right? Then the shape is parabolic shape. Right? Now, the third influence is, right? Throughout the length of the line, the point A is a tower point, B is another tower point. So, whatever the tension from A to B at any point from a transmission line, the tension is a constant value. So the tension at any point is constant. So this is another influences, right? Right? Always tension should be placed in a tangential direction. For suppose if you take a point here, the tension will be tangent. Or if you place here, the tension will be tangential. Tension will be tangential. Tension will be tangential. That means each and every point, the tension is a constant value. Right? The tension each place tangentially. Right? So this is another point. So fourth one is, tension at any point is tangential. So each and every point we have horizontal tension and vertical tension. If you take this one, this is a horizontal and this is a vertical. Horizontal, vertical, horizontal, vertical. But at midpoint you don't have any vertical because there is no pressure. So there is a turning moment, right? So what are the influence, what are the observations that we get from the transmission line curve? The first one is, if the load is assumed to be uniformly distributed and concentrated at the midpoint. So then the curve is quaternary. So what is a quaternary curve? If the feet, that means the span should be less than 1000 feet, then the curve is a quaternary curve. Greater than 1000 feet, then the curve is a quaternary curve. If less than 1000 feet, so then the curve is a parabolic curve. So if it is a curve is a quaternary, so we will get accuracy result, right? And after that, if the load is uniformly distributed throughout the length, throughout the line, then the curve is a parabolic curve, right? And at any point from A to B, from a transmission line, the tension is a constant value. So at any point, the tension is a constant, right? So after that, the tension which is having a tangential direction, tangential force, right? So which is having a horizontal section, which is having a vertical section, right? Now, what are the factors that affects the tension? This is very, very important. Right? We'll discuss about factors affects the sag. Right? The first point, sag must be depends on a weight of the conductor. Weight of the conductor, right? If the weight of the conductor increases, my sag also increases. For suppose if you have a conductor, if the conductor weight ఎక్కువగా ఉందనుకో, what happen? The conductor will move curves. ఇంకా height కాకుండా curves. That means sag is going to be increases. So first point is over. So weight of the conductor, sag must be depends on a weight of the conductor. And the second one is right, location of a conductor. It also depends on location of conductor. That means in a Canada, Russia, there are the cooling places, right? That means that the transmission line, if this is transmission line is surrounded by the ice, isn't it? If the transmission line is surrounded by the ice, means definitely the weight will be increases. Due to that weight, what about the sag? Sag will be increases. So that the location of a conductor, so the location of a places where your conductor are going to be inserted, so depends on that also your sag is going to be depends on, right? So the location of a conductor also over. Now length of the conductor. Length of the conductor. If the length of the conductor is more, if the length is more, you are going to sag is going to be very more, right? So the length of the conductor, your sag is going to be increases, right? This is one more point. And last one, if the tension is more, so what about the sag? If the tension is tightly lagged, sag ఏమవుతుంది? Reduce అవుతా ఉంటుంది. The tension is more, your sag is going to be reduces. That means sag is inversely proportional to the tension or a tensile strength. Right? Tensile strength. So what are the factors, main factors will affect the sag means? The first one is the weight of the conductor. Alright? So weight of the conductor, how much weight the conductor is having. Alright? So if the weight of the conductor increases, our sag also increases, right? And after that, the location of a conductor, that means the location where the conductor is going to be inserted, means if it is a cool climated areas, then there will be ice surrounded by the conductor, right? If ice surrounded by the conductor means the weight of the conductor will be very increases. That means the sag also increases, right? The length of the conductor, if the total length of the conductor is very high, that means the sag is going to be increases. Correct? After that, if a tension is going to be increases, morely tighted means what about the sag? Sag is going to be reduces. So the tension is which is inversely proportional to the sag. So these are the factors; those are affecting the sag value. Right, in this session, what you discussed, that means what is the shape of the curve, what is a catenary shape, what is a parabolic shape, and after that we discussed about when we can call it as a catenary shape, when we can call it as a parabolic shape, right? After that, what is the best design, what is the best condition to take the sag value, right? What are the factors, what are the influences affect from the diagram itself, right? So what are the influences? If the load is assumed at the center point, then we can call it as a catenary shape. Throughout the load, then we can call it as a parabolic shape. Throughout the line, tension is a constant value. The tension always plays a tangential direction, so each and every point that it has some tension, the same tension which is have a horizontal and vertical position itself, right? And after that, we discussed about what are the factors that are going to be affects the tension. Right? There are four more factors is there to affect the tension, affect the sag. So what is that weight of the conductor? If the weight of the conductor increases, your sag is going to be increases, right? And the location of a conductor, ice loading, climatic conditions, definitely the sag will be increases. After that, the length of the conductor. If the length of the conductor is increases, your sag is going to be increases, right? Sag is directly proportional to square of the length. We'll discuss derivation itself there. From that you'll easily understand. Right, if the tension is going to be increases, what about the sag? Definitely, if the tension means tightness is increases, what about the sag? Sag is going to be reduces. Right, definitely what happened, there must be a breakdown occurs. That's why you have to maintain tension and sag must be within the limits. That's my perfect, ensure that you are perfect condition of a sag with all advantages itself, right? So these are the things that we covered till now. In the next session, the sag calculation for different heights. Right? Thank you very much.